Example 5 is again another constraint maximization problem. Here we're given kind of the background of the problem, and we're asked to solve it ourselves. So one thing I want to think about is that here we're given a market response function. So we want to find out how much advertising we put in and how does that correlate with sales. So we have our sales function, which is a function of X, which is our advertisement in circulars, and Y, which is our advertisement in newspapers. Now, for those of you who don't know, newspapers are these kind of things. So they come out in this paper, you open them up, they have stories, you read all about them, you don't actually use a computer. Those are newspapers. So we want to put an ad in a newspaper or in a circular. We want to find the optimal advertising plan, given that we have an advertising budget of $180 per period. Now, to put an ad in a circular is $1 per ad. Put an ad in a newspaper is $4 per ad. So first we want to do is find the optimal advertising plan. And once we do that, then we can look at information about the Lagrange. So let's find the optimal advertising plan. So first off, we want to think, what are we trying to maximize? What are we trying to minimize? So here we're trying to maximize our sales such that we satisfy our budget. So for every dollar we spend, or for every newspaper ad, it's going to cost us $1. For every circular ad, which is X, it's going to cost us $1. And for every newspaper ad, it's going to cost us $4. So if we put all of our money into circulars, we can produce 180 of those. So we want these to be less than or equal to 180. So that's our constraint. So we're optimizing our sales function subject to this constraint. So let's go ahead and insert that into Excel. So here we have X and Y, which is our circulars, as well as our newspaper. And our sales is equal to 420 times X minus 2 times X squared minus 3 times X times Y minus 5 times Y squared plus 640 times Y plus 1725. That is our optimal sales equation. Now we have a left-hand side and a right-hand side. The left-hand side is equal to X plus 4 times Y. Our right-hand side constraint is that we have a budget of 180. So now that we set this up, we just need to go to Solver. And we're trying to maximize sales by changing X and Y with the constraint that our left-hand side is less than or equal to our right-hand side. And therefore, the best we can do is produce 76 circulars and 26 newspapers. That will increase our sales, make our sales 29,425, and we satisfy our constraint. But now the question is, we notice that this is a binding constraint. We're spending $180. The question we want to ask that's brought here is, use the Lagrange multiplier to estimate the effect on sales of a $1 increase in the advertising budget. Well, what the Lagrange multiplier tells us is it tells us the change in our objective function, in this case sales, with a change in our constraint. So if our constraint goes from 180 to 181, we want to know what happens to our sales. So rather than do that and change the right-hand side constraint, run solver all the way again, let's run solver, click solve. On the right hand, on this, let's click on sensitivity report and click OK. So we still get our answer, but it creates this new tab called sensitivity report. We open that up, and I'm just going to copy and paste this over and just paste it right here. What I'll notice is it gives me my Lagrange multiplier, which is equal to about 38. So what that tells me is that if I increase my right-hand side constraint by 1 unit, my sales will increase by 38 units. Well, let's see if that's true. So right now I have sales of 29425. If I add 38 units to that, I should get sales of 29463. So let's go back here, change our constraint to 181. And as I run solver again, I should get my left-hand side constraint to be, or rather my sales, 29463. So let's solve it out. And with a rounding, I get exactly that. meaning that if I increase my constraint by 1 unit, my sales will increase by my Lagrange multiplier, which is 38 units.